Hi, welcome to product review by watthour. In this video we are going to do the review of this Hangzhou Raiden DPH3205 32 volts 5 ampere back boost converter. I'm going to explain the features of the module, specification, then we are going to have a look at inputs, outputs, then the settings of the module will be explained and how to set it up. After that I'm going to show you how to charge a lithium battery, 38 degrees beside it, this area, and then we are going to test it with maximum input and maximum output power with all standard voltages. Now input is 24 volts, output is 32, this is a boost, 160 watt is the output, input current is 7.27 ampere. Let's get started with this. This is the Hangzhou Raiden DPH3205 160 watt or 5 ampere back boost converter. This is a detailed video, so please use chapters. On the larger screen, click on this area of the player so you can see all the chapters, and then click to move to that section of the video. On your mobile device you will see the menu. When you touch it, you'll see all the chapters, and touch to move to that section of the video. So first, DPH3205 module will be explained. Briefly, components will be viewed, and then settings will be explained, how to set it. And then I'm going to do the demonstration of input-output voltage, display accuracy of voltage and current, and also demonstration of charging lithium fade battery. And also I'm going to test the output ripple voltage, test the switching frequency, multiple input and output voltages. Input voltage is 6 volts to 40 volts, and output voltage is 0 to 32 volts. Voltage resolution is 10 millivolts. Current resolution is 1 milliampere, and we have constant voltage, constant current, display LED color, and soft start, no, and cooling fan, yes, it has a cooling fan, and we have memory shortcut of M1, M2. You can jump directly with a preset value, and also we have data group of 10 memory, M0 to M9, and the default power can be set to yes and no. When you turn it on, it can turn on automatically, or it will wait for you to turn it on. We have overvoltage protection, overcurrent protection, and overpower protection. And also it has reverse input polarity protection. We'll do the tests with input voltage of 40 volts, output of 30, 24, 18, 12, 8.4, that's a charge voltage, 5 volts and 3.3 volts. Then I'm going to change the input voltage to 24 volts and output of these voltages with 18 and output voltages, and with input of 12 volts and these output voltages, input of 8 volts with these voltages. And please don't forget to subscribe. This is the package. Let's just open it. Nothing else. With this card and QR to download the manual, and let's scan it. Already it's found, so it is taking you to media fire, and we have 3 folders. We can, as you can see, this is the wrong version. Module, this has been protected very well. So, and this cable, 2 sets of cables, and the display panel. The module feels very solid. Very nice design, all the components, labeling, as you can see. This is very simple. So this is the input. On this side we have plus and minus. 2 of them are, as you can see, they are all connected. This piece, these 2 pins are connected, so this is positive, and these 2 are negative. So do not worry, it's just for adding more wires if you want to reduce the voltage drop on your wire. The same way on this side, negative and positive, and here, as you can see, these 2 pins are already connected together, and these 2 pins are connected. So these two are for negative and these two are for positive, and the same way here, these two are negative and these two are positive. Any setting here, the very nice and solid, no shaking, nothing for these inductors. This shunt resistor is close to the output because it measures the current of the output, and the voltage that appears across this is referring to the current, and this microcontroller is deciding with some op-amp to control the output voltage. On this we have LCD, and then it says key, and here as well we have LCD and we have key. Let's plug this one to LCD, to the key, so the connection is very nice. You won't be making any mistake. Now it's time to thumb up the video and also hit the subscribe button. Now let me explain the settings. The output can be turned on and off using this button, but you cannot turn off the screen. So if I press it now, you see that the output voltage is 10 volts and the current is now 3 ampere. If I turn it off, you will see the set value 10 volts and 4.1 ampere, that's the current. So these values will be applied here when you turn it on. And because it is set now 4 and the load is taking only 3, so it's not affecting. But if the load increases above 4.1, you can see now it says CV, constant voltage. This will change to constant current. Using this rotary encoder, which you can push and rotate, you can do some tasks. And if I hold it for more than 3 or 4 seconds, you see the screen is now locked. All the buttons now will be deactivated and will not affect until you press it for 3 to 5 seconds until it's unlocked, and then you can do to change the output voltage. Either if the output is on or the output is off using this button, you can set the value here. If I press this button V, that's for the voltage, and you see the highlight there, I can rotate and change the value, or I can press it to go to the next value or to the next one, and here I can change the voltage, for example 13 volts. If you want to change the current, if you don't touch it for a few seconds, it will exit, or if you press this button for A ampere, you can set the current, for example 5 ampere or 4 ampere, that you whatever value you want to set. This button, if you press and hold it, it goes to memory 1 default setting. It says M1. So M1 is set to 5 volts, 5 ampere, and output is off by default, meaning when I brought that M1, automatically it turned off. And this is M2. Let's hold it, and it is M2. It's the same value, it was not set. So these are 2 shortcuts, but you can have up to 10. Now let me show you. When you press set for a shorter period, you will see these values one by one. That's V set, that's the voltage set, that's the current 5 ampere set. This is the setting for over voltage protection. For example, if you don't want in your preset that you work with something at 20 volts and you don't want to by mistake go above 20, set the over voltage limit, and here you can set over current protection, so you can never set it above the limit that you set, and over power protection also you can set the power. So these 3 important protection will help you not to make mistake in certain project that you work. And this is the screen brightness, and the last one is the memory preset, which I'm going to show you. For each you can go up and down like that. Once you come, then and it moves and you can change it, or press this again, it goes to the next one, and press it, it goes to the next one. If you just press set, it will exit back, come here. If you press it again, you will exit from the screen in total. But let me show you. You can come to the next one, press this rotary encoder and set the value, press it go to the next one. The same way you can set the over voltage protection, over current, over power. And here, if I press it, let's set the brightness to the maximum because I'm recording it, and then press this. And here we can set the default. M0 is the default when the device turns on or anything you do. If you don't select any memory preset, M0 is there, and it is set to off. So if I come here and press it again, now on, meaning as soon as this device receives power, the output will be on. Now let me show you how to set the presets. I'm going to show you 2 of them, so you know the same way you can do 10. Let's set memory preset. So press set, and with this arrow, bring it down to preset. And you see here it says M0. Press this knob and make it M5. Now it's 5. Press it again. You come here. Let's say you want it to be able to turn on at boot. Once you're done with these 2, press the set. It comes back. Now let's go. After setting the number, we go to set the values. All these values can be set, including the brightness and everything. But let's go and set the voltage to 12 volts. I'm there. 12 volts. Then press it to come back to current, come down. And here, let's say you want to set it to 4 ampere. And now, on this screen, just press and hold, and you will see here M5. This M5 appeared. Now this has been saved. Now let's do M1. For example, let's go M1, and then I want it to be off, and then let's set it 8.4 volts for 2 lithium battery charge. Let's say you want to charge your battery 8.4. Come with the current, and you want to charge it with 2 ampere. After that, it's M1. Everything is done. Just hold it for a few seconds until you see M1. This M1 appeared. You're done. Press this and exit. Now M1 and M0 has shortcut. If I press this and hold it, M1 came and 8.4 volts and 2 appeared. Now if you want to go with other presets, press and hold this, and you see the numbers. Now let's go with different presets. Our was M5, and press it and press exit. You see the voltage and current. So this way, with long press, you can bring the presets. With long press of this button, you go to memory preset 1. With long press of this button, you go to memory preset 2. Now in this case, the voltage is 12 volts and 4 ampere. Now let me turn on the output. As you can see, 12 volts, 3 ampere. My load is taking 3 ampere. If the current exceeds above this value, above 4 ampere, then you will see constant current. Let me go 4.1. So you see, CC, 4 ampere, it's keeping it 4, but it drops the voltage. So that's the meaning of constant current. So you keep the current constant, you don't worry about the voltage. Now first, let's see the voltage reading of the display, and also the minimum and maximum. So let me turn it on, and we see 12.1 or 12, and that is 11.99. Very precise, so that's acceptable. Now I went to the maximum, 30 millivolts discrepancy. So now this is 32, and we are reading 31.97. So that's the maximum voltage with the input of what we can set. So 0, 0, even we can set 0. Amazing. It's 30 millivolts. We are reading 25 and 30. And here we read 36. Let's go exactly 1 volt. So only 6 So that is 1 volt with 2 digits. Absolutely amazing. So voltage reading is good. Very minimum is 0, maximum is 32. Now let me show you how we can charge a lithium battery. We have to know the following first: maximum charge voltage, we must know it. We must know also maximum charge current. And for lithium ion NCR18650, the maximum charge voltage is 4.2 volts and people call it 3.7 volts. That's a nominal voltage. And charge current is maximum. You can go 1.65, but you can go lower, but that's the maximum. For lithium iron phosphate, when people call it 3.2 volts, it's actually the charge voltage is 3.65 volts. So we have to know this before we proceed with the charge. And the charge current, you can look at the data sheet, but that's the maximum. You can always go with the lower. The maximum charge voltage is 4.2 volts and people call it 3.7 volts. That's a nominal voltage. And charge current is maximum. You can go 1.65, but you can go lower, but that's the maximum. For lithium iron phosphate, when people call it 3.2 volts, it's actually the charge voltage is 3.65 volts. So we have to know this before we proceed with the charge. And the charge current, you can look at the data sheet, but that's the maximum. You can always go with the lower. So please don't forget to subscribe. And here for this battery, I'm going to set the voltage at 4.2 volts and the current. I already used a preset number 9. Let me hold this button until you see here, so I can go to number 9. Once you are at that number, just press this and pay attention. The voltage and current will be set whatever we have here. So 4.2 volts, 1.65. This is ready. Connecting the terminals to the battery, positive to positive and negative to negative. By default, this is off, so let's turn it on. And as you can see, the voltage is now not 4.2 because CC is turned on, constant current, and brings the voltage down and keeps the current wherever you set here. So now it shows 1.65, and this is also a 4 milliampere extra, does not matter. And now as the battery fills up with a charge, this charge will be reduced slowly and the voltage will increase until it reaches 4.2. When it reaches 4.2 volts, the current will be 0. And that is when we know that the battery has been charged fully. And here, if you want to charge, let's say 4 lithium battery, they have been connected in series. This is negative, positive and negative, so they are connected like that. And we have 2 terminals left. It is 4.2 volts times 4, 16 volts should be set. Because they are in series, the same current will go through all of this. I've saved it into memory number 8. Just press and hold this until you see here 0, and then go to 8 and then press set, and you will see this is now 16.4, and I'm charging it at 3 ampere. When you charge it at 3 ampere, the same current will pass through all of this. Now I have not connected anything, these are just extra wires. I'm going to connect the terminal here, positive to the positive and negative to the negative, and let's turn this on. And as you can see, I'm charging it at 3 ampere, but the voltage is 15.38939. And again, when the battery capacity fills up, this voltage will increase and the current will slowly decrease. When the voltage reaches at 16.8, this current will be 0 and the battery will be charged fully. Here is my setup. Input current passes through this ampere meter where we will see the input current, and then the input have been connected in here, and the output, these 2 wires, these have been connected to my electronic load. This is the electronic load DL3031, and these are the 2 terminals that from the circuit will be connected in here, and we will see the voltage here and the current Zoomed in so you can see properly all this, including the input voltage. Now I'm doing output voltage of 32 volts, 160 watts. As you can see, with 40 volts input current is 4.186. And here is the efficiency. Output is now set to 30 volts and current is set to 5 ampere. Let me go with 5 ampere power drawing from this device. So this is now supplying 5 ampere. And as you can see, the voltage has dropped and it says CC. So we have to check if the current limit have been set here. Because this is set to 5 ampere and this is 5, this is exact. So let's set the input current to 5 point something. So 5.1. Now I set that to the fan has started now running, but it is very quiet. Perhaps the speed of fan is being also controlled. We will see if it is speeding up or not. Input current is 3.9 ampere. Output power is 149.7 because of this voltage discrepancy. And here now I connected these two wires for voltage sensing. This electronic load will sense the voltage from here directly using these wires. As you can see, even output is not on. We can read 34 milliampere. So this module is consuming 35 milliampere, 34 milliampere continuously, including this 14 milliampere that my electronic load is taking. Let me disconnect my electronic load so you will see here. So now 23. So this module is taking 22 or 23 milliampere continuously. If I connect my electronic load again, now output voltage is 24 volts. Let's go with 5 ampere. 24 times 5, 120 watts. It's very accurate. Input current is 3.15 ampere. And here is the efficiency. Now input is 40 volts, output is 18 volts at 5 ampere. Input current is 2.41 ampere. And here is the efficiency. Input is 40, output is 12 volts, 5 ampere 60 watt, input is 1.65 ampere. Here is the efficiency. Now output is set to the charge voltage of 8.4 volts. This is through lithium battery, 5 ampere with input 40 volts. That's 42 watts with input of, here is the efficiency. Now output is 5 volts, 5 ampere, input current is 767 milliampere. Here is the efficiency. Have a look at the thermal image, and it shows 39 degrees Celsius is that spot, the hot spot in here. 38 degrees beside it, this area. So it's very cool. The fan, as you can see, is very cool. Now output is set to 3.3 volts with input 40 volts, 5 ampere. Here is the input current, 551 milliampere at 3.3 volts. 16.57 watts is the output. Here is the efficiency. Our input voltage is 30 volts. This is a new input voltage. Output is now 24 and 5 ampere. Input current is 4.28 ampere. Here is the efficiency. Output is 18 volts, 5 ampere volts. Input current is 3.26 ampere. Here is the efficiency. Now output is 12 volts, 5 ampere with 30 volts input. 2.23 ampere is the input current, and here is the efficiency. Now output is 8.4 volts, 5 ampere. Input current is 1.6 ampere with 30 volts. Here is the efficiency. Output is 5 volts, 5 ampere with 30 volts input. 1.03 ampere is the current. Here is the efficiency. Output is 3.3 volts, 5 ampere. Input current is 0.74 ampere at 30 volts. Here is the efficiency. Now I set a new input voltage 24 volts. Output is now set to 18 volts, 5 ampere. Input current, as you can see, is 4.125 20 watts, and here is the efficiency. Now output is set to 12 volts with input 24 volts at 5 ampere, 60 watts. Input is 2.82 ampere, and here is the efficiency. Now output is set to 8.4 volts, the charge voltage, input 24. As you can see, output is now set to 5 ampere. Input is 2.04 ampere. Here is the efficiency. Now input is 24, output is 5 volts, 5 ampere. Input current is 1.3 ampere with 25 watts at the output. Here is the efficiency. Now output is 3.3 volts, input 24, 5 ampere. Input current is milliampere, and here is the efficiency. Now I started new input voltage of 18 volts. Output is 12 volts, 5 ampere. Input current is 3.8 ampere, and here is the efficiency. Now output is 8.4 volts with 5 ampere. Input current is 2.75 ampere, 42 watts, and here is the efficiency. Now with 18 volts input, 5 volts, 5 ampere is the output. Input current is 1.76 ampere, and here is the efficiency. With input of 18 volts, output is 3.3 volts, 5 ampere. Input current is 1.27 ampere, and here is the efficiency. Now I started new input voltage of 12 volts. Output is 8.4 volts for charge voltage, 5 ampere. Input current is 4.17 ampere, and here is the efficiency. with input of 12 volts, output is 5 volts. Now 5 ampere, input current is 2.65 ampere, and here is the efficiency. With input of 12 volts, output 3.3 volts, 5 ampere, input current is 1.92 ampere, and here is the efficiency. Now input is 8.4 volts, output is 5 ampere, 5 volts, input current is 3.8 ampere, 84 ampere, and here's the efficiency. Input is 8.4 volts, output is 3.3 volts at 5 ampere, input current is 2.75 ampere, here is the efficiency. Now it's time to thumb up the video and also hit the subscribe button. Now the input is 6 volts and I've set the output to 32 volts. When I turn it on, you will see now it's boosting 32 volts, and you will see the output voltage in here as well. But I'm going to put 1 ampere when I turn it on. With 1 ampere, as you can see, voltage has dropped, so it does not work with 6 volts. Now pay attention, it reduces, because the current is maximum 1 ampere, it reduces the voltage. Instead of 32, we are getting 21, but I'm going to increase the input, so pay attention. So the voltage is now increasing. Even 7 volts, at 7 we are getting 27, not 32. So I'm increasing it. Eight volts. Still we are not getting. 9 volts we are not getting. So it's 9 now. So at 10 volts we are getting 32, but that's only 1 ampere. I've not gone higher. So in order to get some voltage, if I increase the current, I'm not sure. Let's go 2 ampere to see. So 32 becomes 2, so it cannot handle 2 ampere. Now I have to increase the input again. As you can see, I have to go to 11. But here is a problem. Now input, and here, now input current is 6.8 ampere. So the current has increased. Maximum input current is allowed to be 10 ampere, but let's go. Now it is now 11 volts, 10.94. We are getting 2 ampere. Let's go 3 ampere. The voltage dropped, and we have reached 10 ampere. So with 11 volts, you can get 32 volts, but only 3 ampere, because we have reached 10 ampere maximum. More than this is not allowed. Input of 11 volts, output 32 volts, we get 3 ampere. Input current is 9.89 ampere, and here is the efficiency. Now input is 15 volts, output is 32 with 3 ampere. Input current is 6.92 ampere, and here is the efficiency. That's the maximum we can get from 15 volts. Now input is 18 volts. I just increase it a little. This is a charge voltage 3. Let me go with 4 ampere. So the voltage is fluctuating, so 4 ampere does not work. Now input is 18 volts. Output is 32 volts with 3 ampere. Input current is 5.74 ampere. And here is the efficiency. Let me increase it. Now input is 24 volts, output is 32. This is a boost. 5 ampere maximum, 160 watt is the output. Input current is 7.27 ampere. And here is the efficiency. Input is 12 volts, output is 24 volts. This is double. The maximum current is 5 ampere. Input current is 11, so this is not allowed because the maximum is said to be 10, so we have to reduce the current. Now if we get 4 ampere with 24 because of the manufacturer's suggestion, then input current is 9.18 ampere at 24 volts, 4 ampere output. Here is the efficiency. So input is 18 volts, output 24. That's a boost with 5 ampere, 120 watts. Input current is 7.5 ampere. And here is the efficiency. Now input is 12 volts, output is 18 volts, 5 ampere maximum. We are getting 90 watts. Input current is 8.76 ampere. And here is the efficiency. Now another boost test. 12 volts input, 15 volts the output, 5 ampere maximum. Input current is 7 ampere. And here is the efficiency. Now let me show you the protection features. First, over voltage protection. Press set and then go down OVP with this arrow. Let's say you don't want to go above 24 volts. So press this button and let's set it to 24. And press exit and press exit. Now over voltage protection is set to 24 volts. As you can see, input is 30 volts. Let me turn the output on. Now 5 volts, 3 ampere is being drawn, and we set this to not allow 24 volts. Now I'm touching this and going to 5, and let's see, I'm setting it 10 volts, 12 volts, that's fine. 15, and let's go 20 volts, and pay attention. Now I go to 23, that's fine. Now 24, automatically it turned it off. The output is now off, it will not allow it. So 24 is included. Now if you want to not include the 24, then come here and make it 24.1. Now exit to less than 24. Output is on 23, and let's include 24. And as you can see, 24 is allowed, and only 0.1 will cause this to turn on. So if I go 21, output is turned off. So that is over voltage protection. Now let me show you over current protection. Press set, come down, OCP, over current protection. Let's say you are working with a project that anything above 3.5 ampere will harm the project. So press this and 3.5, anything above 3.5. So I have to change this like 3.51 or 52. So this will just turn on. Now this is set, press exit and exit. Let me turn the output on. As you can see, 24 volts, 3 ampere, and I'm increasing the current. You will see it here. So now I'm going 3.1, it's working, 3.2, 3.3, 3.4, and that's 3.5 is still allowed. But pay attention, this will turn off. And blocked it, and your device is being protected using OverCurrent Protection. Now let me show you OverPower Protection, so you can set certain power regardless of the voltage and current, and it will protect it. Because this goes with maximum of 160 watt. Let's say you want to protect a device over 60 watts. Press set, go down until with this arrow until you see OPP. You see it says 171, and let's say 60 watt. $60.1 watt. So anything above 60 is included, 60 will be allowed. Above that, it will take effect. So press set. Now I have turned it on with 20 volts, 20 ampere, that's 40 watts. So if the output is above 60 watts, it will turn off. So let me do that. So I'm increasing it. You just read it here. 44, 46, I'm increasing 50, 52, 54, and 56, 58, 40, and turned off. So as soon as it went above 60 and turned off. So this was OverPower Protection. Now I've connected my oscilloscope to the output to measure the output ripples, and here you can see my output is 32 volts, maximum current 5 ampere, that's 160 watts. And here the output ripple from some spikes that you see is 45.6 millivolts at 5 ampere, and switching frequency is 29.8 kilohertz. 15 volts, 5 ampere. Switching frequency has not changed, 29.8, and output ripple is 14.4 millivolts. Now I set output to 5 volts, 5 ampere. The ripple is 7.6 millivolts, and switching frequency now increased to 35.2 kilohertz. At 1 ampere is 30 kilohertz, the switching frequency, and output ripple is 8.32 millivolts. And here are my conclusion remarks for this DPH3205 160 watt 5 ampere back converter. I have no affiliation with this company. I've just purchased it with my own money, and I'm doing an honest review. If you look at the features, it's easy to use. The setting is very easy, except the memory presets, which you have up to 10 memory. That's a great feature, but the setting was a little not intuitive, which I've explained it very well. If you watch it, you will learn that. It has constant current at 5 ampere for all voltages. That's a great feature, and I tested it and it passed all the tests. So it works with 5 ampere, and then charging the battery with CC is a great feature, so you can charge your batteries. And it has less than 5 milliampere ripple voltage, which I've just shown you on oscilloscope. Then it has protection over voltage protection OVP, which I've tested it. It works perfect. Over current protection OCP, I tested it, and it passed all the tests and it works, and OverPower Protection OPP also works perfectly. So these protections will make your device very trustworthy to use. In terms of efficiency, I've tested it, and when I set the input with 40 volts and output at 30, as you can see, it is above 95%, amazing. And then I changed it to 24 volts, and in 18 volts it is just above 90 or 92%, as you can see. And then at 12 volts it's around 90 point something, and then 8.4, that's a voltage, charge voltage, it is just about 87%. And then when you go to 5 volts it will be decreased further, and at 3 volts it's around 75%, so it is being decreased. At 30 volts the same, it is above 90 but less than 95, and it is being reduced when you go to 3.3 volts. At 5 volts, as you can see, it is around 80%, so efficiency is being dropped as the output voltage is dropped. 12 volts the same, it's above 90 and efficiency is being dropped below 80. And at 18 volts, as you can see, at 8.4 volts it's around 84%, and it goes just above 75 at 3.3 volts. At 12 the same, at 12 volts, as you can see, it's around 85% at 8.4 volts, and at 5 volts it's just below 80%, and at 3.3, as you can see, it is just above 75%. And when you go with 8.4, the voltage is being reduced. At 5 volts we get just above 77%, and at 3.3 volts it's just above 70%. And here is the result for the boost conversion. This is a test for input of 12 volts. I did output of 32, 24, 18 and 15. And here are the currents that you can get. With 32 volts you can get 3 ampere because we are reaching 9.4, that's 10, close to 10, so it did not work. And also at 24 volts we got 4 ampere, and 18 and 12 we got 5 ampere, which is the maximum. And these are the input currents, and here, as you can see, the efficiency is between 86 and 87% to 89%. With input of 18 volts, then I got 24 and 32, I got only 3 ampere, and at 24 I got 5 ampere. Again, 87 and 92% was the efficiency. When I connected input of output 32, I got maximum of 5 because the difference is very little, and input current was 7.26 ampere. Efficiency was 91.8, 92%. Thank you for watching. This was the full review of this module. Please thumb up the video and don't forget to subscribe. If you have comment or question, post it at the comment section below. I try to answer and reply. In this video we are going to do the review of this 50 volts 20 ampere Wurji WZ5020L back converter, 20 ampere or 1 kilowatt. We're going to test it at different voltages, up to 55 volts at the input and up to 20 ampere. Needs more current, so the constant current is turned on, but we are not worried. Input current 10.8,